Okay, what we're going to be taking a look at now is, after we've kind of got a basics, is we're going to take a look at the worksheet that I passed out as notes today. I'm going to be doing these on my own individual graph paper. I'm going to kind of walk you through how to do each problem and how to do each step. So our first problem that we have is just simply 1 over divided by x minus 2. So when we set up 1 divided by x minus 2, our first step is we're going to determine if there's a y-intercept. If there's a y-intercept, then x equals 0 should give us a value. So when I've got 1 divided by x minus 2 would give us 1 divided by negative 2, or negative 1/2. It's going to tell us our y-intercept is at 0, negative 1/2. The second item, we need to determine if there are any x-intercepts. So to find our x-intercept, we set the function equal to 0. So 1 divided by x minus 2 equals 0. I'm unable to solve for x while it's in the denominator, so I will start by multiplying each side by x minus 2. So 1 is equal to 0 times x minus 2 would be 0. Okay, which is obviously not a true statement. Since 1 does not equal 0, that's actually going to tell us that there is no x-intercept. Our third item we want to look at is we need to determine if there are any holes. And for us to determine any holes, we said that we had to be able to factor and reduce the equation. 1 over x minus 2 does not factor, no factors, no holes. Okay, our fourth item, a vertical asymptote. Set the denominator equal to 0 and we solve for x. So x minus 2 equals 0, where x equals positive 2. Our fifth item is we need to determine our horizontal asymptote. So in this case, with 1 over x minus 2, I have degree 0 in the numerator and degree 1 in the denominator. So that's going to be a larger degree in the denominator. Bigger on bottom is Bobo, or y equals 0. So when I go to graph my function, got my graph, I'm going to start by putting my asymptotes on the graph. So I've got y equals 0 as my horizontal, and I have x equals 2 for my vertical. So when I go to actually graph my point, I'm going to choose one point to the right and one to the left. As long as it's only one asymptote, I can do that. If it's multi-vertical asymptotes, we want to go closer than just one. So I'm going to use x equals 3 would be one point to the right, and x equals 1 for one point to the left. I'm going to substitute those into the equation and solve. So 1 over 3 minus 2 would be 1 divided by 1, or 1. So my next point would be 3, 1. And I know it's not going to cross my asymptotes, so it's going to be nice and framed to the left and right. When I substitute x equals 1, I'd have 1 over 1 minus 2, be 1 over negative 1, or just negative 1. So I also have the coordinate 1, negative 1. And I'm going to have it move as close to the asymptotes as possible. I get a nice pretty picture that looks something like that. Our second equation, we have y equals negative 4 divided by x plus 2. So on this function, I'm going to go through the exact same procedure I went through on the last one. So I'm going to look for a y-intercept first and foremost, where I substitute x equals 0. So I have negative 4 divided by 0 plus 2, be negative 4 divided by 2, which is negative 2. So my first coordinate is 0, negative 2. The second item I'm going to do is I'm going to look for any x-intercepts. So I'm going to set y equal to 0 and solve for x. In this case, negative 4 over x plus 2 is equal to 0. I multiply each side by x plus 2, and same song, different verse. I'm left with negative 4 equals 0, which again isn't true, so that's going to tell us there's no x-intercept. Okay, step 3, we can kind of skip because there was no factoring to be done on this equation, so that's going to imply that there's no holes in this equation either. Step 4, we're going to look for our vertical asymptote. This is where we set our denominator equal to 0 and solve for x. X plus 2 equals 0, x equals negative 2. And finally, we're going to look for our horizontal asymptote. So when we have negative 4 over x plus 2, we have 0 x's over 1 would be bigger on bottom, tells us y equals 0. So we've got our horizontal asymptote at y equals 0, our vertical asymptote at x equals negative 2. We have no x-intercepts. We have a y-intercept at 0, negative 2. And likewise, we're going to also be able to tell that it's not going to cross the horizontal asymptote ever. The way we're going to know it's not going to cross the horizontal asymptote is we've already tried to set the equation equal to 0 and solve. Okay, we got a false statement. It's not going to cross that horizontal asymptote. So now we need to put it together on a picture. So on our graph, first thing we have is our horizontal asymptote at y equals 0, or the x-axis, and we have a vertical asymptote at x equals negative 2. Okay, the next thing we had was we had our y-intercept at 0, negative 2. And we know it's not going to cross the green lines. So just like the last problem, I'm going to choose one coordinate to the right of the vertical asymptote. So since it was at negative 2, I'm going to use x equals negative 1. And I'm going to go 1 point to the left, which means I also need to check x equals negative 3. So if I substitute negative 1 for x, I've got negative 4 over negative 1 plus 2. Or negative 4 divided by negative 1, or positive 1, would be negative 4. So I have negative 1, comma negative 4 as another coordinate. So negative 1, and I can kind of tell that this is how my graph is going to go as it gets closer to the asymptotes from both sides. Our second value, x equals negative 3, when we substitute for x, we've got negative 4 over negative 3 plus 2, negative 4 over negative 1, or positive 4 this time. So we have the coordinate negative 4, negative 3, positive 4. We're going to kind of see that it's going to go up as we get closer to the asymptote from the left side, and it's going to even off with our horizontal asymptote as we get farther to the left. Our third function, 3x over x minus 1. 3x divided by x minus 1. So when we're looking at this function, we're going to start by looking for our y-intercept. So our y-intercept, f of 0, would be 3 times 0 over 0 minus 1, would be 0 divided by negative 1, or 0. It's going to tell us that this graph is going to go through the origin. It's going to go through 0, 0. So now when we look for any additional x-intercepts, we set our equation equal to 0, 3x divided by x minus 1. We're left with 3x is equal to 0, where x equals 0. So that's going to tell us again it has an x-intercept, and that x-intercept is the origin. So again, we are left with an equation. Cannot factor, there are no holes. Our vertical asymptote, we set our denominator equal to 0, x minus 1 equals 0, or x equals positive 1. Our horizontal asymptote, in this case we have 3x divided by x minus 1. We look at our coefficients because we have equal terms. We've got x to the first, so we'd have y equals 3 over 1, or just 3. Okay, will the function ever equal its horizontal asymptote? Let's kind of check. So we set 3x divided by x minus 1 equal to 3. So I'm going to start by multiplying each side of the equation by x minus 1. That will leave me with 3x equals 3x minus 3. So when I group my x's on the same side, that will leave me with 0 equals negative 3, which is not true. Since that's not true, it will not cross the asymptote. So now we need to graph the thing. So our first value we had was we know it needs to go through the origin. We know we have our horizontal asymptote at y equals 3. We have our vertical asymptote when x equals 1. And so I'm going to check one coordinate to the left and one coordinate to the right. So one point to the left would be x equals 0. I've already kind of checked that, so I'm going to have it get as close to my asymptotes as I can get it. Now to the right, I'm also going to check x equals 2, one space to the right of my asymptote. So when I substitute that in for x, we'd have 3 times 2 over 3 minus 2, be 6 over 1, or 6. So my second coordinate would be 2, comma 6. And I can kind of tell that it's going to get as close to my asymptotes as it can. It will always get as close to the asymptotes. As we get closer to a vertical asymptote, we'll always even off with the horizontal asymptote on the far left and the far right side of your graph. Okay, so question 4. This is the first equation where we actually have to do a little bit of factoring. So the first thing I'm going to do is I'm going to take the equation of x plus 2 and I'm going to factor it, which would leave me with x minus 3 times x plus 2. So this time I've got a common factor in both the numerator and the denominator. So I can reduce my equation, which would leave me with 1 over x minus 3. Now I'm going to be able to go back and forth interchangeably between these two, and it's not going to really matter. I'm going to prefer to use my reduced equation as much as possible. So first things first, we're going to find our y-intercept, if it exists. So f of 0 would be 1 divided by 0 minus 3, be 1 over negative 3, or negative 1/3. So my y-intercept is 0, negative 1/3. Next item, my x-intercept or 1 over x minus 3 equals 0. We can kind of see where this is going at this point. We have 1 equals 0, which is definitely not true. Since it's not true, there's no x-intercept. On number 3, holes. So this one will have a hole, and mostly because we had this factor that divided out of x plus 2. So the way we find our hole is we set x plus 2 equal to 0, and we solve for x. So x is negative 2. However, what we need to do is we need to now substitute into the reduced equation. So we'd have y equals 1 divided by negative 2 minus 3, or negative 1/5. So our whole is going to be negative 2, negative 1/5. And when we put that point on our graph, we're actually going to put a hole with an open circle. Our vertical asymptote, we do have one vertical asymptote because we do have one leftover factor of x minus 3, or x is equal to 3. We need to know our horizontal asymptote. So when we have 1 over x minus 3, okay, we have bigger degree on the bottom, which tells us Bobo would be y equals 0. The last thing we need to do, will the equation equal 0? Will it cross the asymptote? Absolutely not. And we can prove that because 1 does not equal 0, so it will not cross. So now when we go to graph this equation, we have our horizontal asymptote at y equals 0. We have our vertical asymptote at x equals 3. We had our y-intercept at negative 1/3. Now we can't really tell between the two lines, so I'm going to just label that 0, negative 1/3. And then we had a hole at negative 2, negative 1/5. And we said we needed to plot that with an open circle. So at negative 2, I'm going to put an open circle. I'm just going to kind of label it. So now, since my vertical asymptote was x equals 3, I'm going to try the next couple of x values to either side, to the left and the right, substitute it in for x and see what I get. So to the left, I'm going to try x equals 2, and to the right, I'm going to try x equals 3. So again, I'm going to substitute into my reduced equation. So 1 over 2 minus 3 would be 1 divided by negative 1, or negative 1. Just going to give me the ordered pair 2, negative 1. So we can kind of connect the dots and see, hey, it's going down and to the left and to the right. So we've got half of our graph that looks like that. So when we try x equals positive 3, we've got 1 over 3 minus 3, or excuse me, when x equals 4, we would have 1 divided by 1, which is 1, which is going to tell us that a second coordinate would be 4, 1 on this graph. So we know it's not going to cross the asymptotes, so as it gets closer and closer, it's going to kind of even off with both of them, which will give us a completed graph for number 4. number 5, again, we're going to take our equation because we have a quadratic and we're going to factor it. Now, it's very tempting to say x minus 3 is a factor. However, this one does not factor to x minus 3, x minus 2, factors to x minus 6, x plus 1. Okay, so there are no factors that can be removed. It cannot be reduced because we do not have a common factor in both the numerator and the denominator, which is going to tell us that this is how it's going to have to be. We're going to have two vertical asymptotes and we're going to have no holes in this equation. So our x-intercept, we said x equal to 0, or we set y equal to 0. So x minus 3 over x squared minus 5x minus 6 equal to 0. We multiply both sides by the quadratic in the denominator, which would leave us with x minus 3 equals 0, where x equals positive 3. Okay, that's going to be in the domain, so that's going to be our x-intercept at 3, 0. Okay, y-intercept. We substitute 0 for x, so we have 0 minus 3 over 0 squared minus 5 times 0 minus 6. Leave us with negative 3 divided by negative 6, or positive 1/2. So our y-intercept would be 0, 1/2. Our vertical asymptote, we're going to take our two factors from the denominator, set them each equal to 0. X minus 6 equals 0, where x equals 6. X plus 1 equals 0, x equals negative 1. Our horizontal asymptote, for x minus 3 over x squared minus 5x minus 6, we have a degree 1 over degree 2, bigger on bottom. So we've got Bobo here. So y equals 0. Will the function ever equal 0? Will it ever equal the y-intercept, or the horizontal asymptote? We can go ahead and determine that it will cross the horizontal asymptote. The reason why? We've already kind of determined it's going to equal 0 in step 1. So we're not going to have any sort of oblique asymptote or slant asymptote due to the fact that it's not bigger on top. So now when we go to graph the function, we have it at a horizontal asymptote of y equals 0. We have a vertical asymptote at x equals negative 1, and at positive 6. Okay, we already have a couple coordinates that we can put on the graph. We had a y-intercept of 0, 1/2. And we had the only x-intercept at 3, 0. Now, if this is the only point where it can cross the x-axis, when I connect these two dots, this is going to have to go up and to the right already. Or up, as we go to the left side of this asymptote, it's going to have to go straight up. The reason why is because I cannot cross down and cross the x-axis a second time. Otherwise, this would have been a 0 of my function. So when I cross my x-axis, now we want to check a couple of values here. So let's go ahead and check. So one point to the left of this, let's check x equals negative 2. So since this was x equals 6 for our vertical asymptote, I'm going to check x equals negative 5, x equals 7. So I'm just going to substitute negative 2, 5, and 7 into my function. So f of negative 2 we'd have -2 minus 3. Now I'm going to use my factored form to work this out. So -2 minus 3 would be -5. -2 minus 3 would be -5, and -2 plus 1 would be -1. So when I continue to work that out, I've got -5 divided by +5 would be -1. So when x is -2, y was -1. Now we know it's not going to cross our horizontal asymptote at any point, or any other point. And we know it's going to get closer to our vertical asymptote as we go. We get a graph that looks kind of like that. So now let's go ahead and check x equals 5, one spot to the left of our second vertical asymptote. We have 5 minus 3 over 5 minus 6 times 5 plus 1. So 5 minus 3 would be 2 over -1 times 6, which would leave us with -1/3. So we have the coordinate 5, -1/3. So like we're kind of saying, it's not going to cross the x-axis again. It's going to go down and to the left as we get closer to this asymptote right here. Now the final value we wanted to check was one spot to the right to determine if it's above or below our horizontal asymptote. So f of 7. So 7 minus 3 over 7 minus 6 times 7 plus 1. So 7 minus 3 would leave us with 4 over 1 times 8 and leave us with 1/2. So my final coordinate is 7 and 1/2. So I know I cannot cross my x-axis, so I'm going to get closer to my vertical asymptote and then closer to my horizontal asymptote as it goes, which is going to give me my completed graph for x minus 3 over x minus 6 times x plus 1. Okay, equation 6, we have -2x squared minus 3 divided by x squared. So neither my numerator or denominator can be factored, so we're just going to have to keep going from there. So with our y-intercept, we substitute x equals 0. We have -2 times 0 squared minus 3 over 0 squared, or -3 divided by 0, which is undefined. Cannot divide by 0. It's outside of the domain. Due to that being outside of the domain, we will have no y-intercept. The next item we need to do, does it have an x-intercept? So we set our entire equation equal to 0, 2x squared, -2x squared minus 3, divided by x squared equal to 0. So I'll start by multiplying each side of my equation by x squared. Which would leave me with -2x squared minus 3 equal to 0. So when I start solving for x here, I'm going to notice something very strange. -2x squared is equal to +3, or x squared equals -3/2. Now, what this is going to tell me, since I have plus or minus I square root of 3 over 2, there's no place for me to put an imaginary value on a coordinate plane. There are no real x-intercepts, or in other words, there are no x-intercepts. Poles. Going to be not applicable because we couldn't factor this thing. Vertical asymptote. This is where we set our denominator, x squared equal to 0, or x is equal to 0. And the final item is our horizontal asymptote, where we look at our leading terms. So we have -2x squared minus 3 over x squared. So equal degrees is Betsy. Equal terms we look at the coefficients. So our coefficients here, -2 in the numerator, +1 in the denominator would be y equals -2. Okay, let's check and see, will the equation ever equal -2? Will it cross the horizontal asymptote? So -2x squared minus 3 divided by x squared, will that equal -2? So to solve my equation, I'm left with -2x squared minus 3 equals -2x squared. We can kind of see where this is going. The x squareds will cancel out when we try to combine them on the same side, which leaves us with -3 equals 0. It's not going to cross the horizontal asymptote. So we have a graph that has no x-intercepts, it has no y-intercept, it will not cross its horizontal asymptote. So let's just take a look at how this thing is going to turn out. So at -2, this is going to be our vertical asymptote. And x equals 0 is our vertical asymptote. So what we need to do now is we need to determine where it's actually going to be. So what I'm going to do is I'm going to go one spot to the right of my asymptote for x equals 1 and -1. I will substitute these in for x and work out the equation. So -2 times -1 squared minus 3 divided by -1 squared would be -2 times +1 minus 3 divided by +1, or in other words, -5 divided by 1, or -5. So we have -1, -5 as a coordinate. So since it's going to be bounded by our asymptotes, we've got the left half of our graph complete. Now let's go ahead and try x equals +1. So -2 times 1 squared minus 3 over 1 squared. This is going to end up the exact same way and leave us with -5 for the y value. So 1, -5. We get the right-hand side is going to look like that. We get a graph that kind of looks like a little letter T. Okay, final problem. So this case, we have 7 is equal to x squared plus 2x minus 3 divided by x plus 4. So this one's a little bit different. This is going to be the first one where we have something that's going to change what we have to do. Mostly because we have a quadratic in the numerator and a linear function in the denominator. So I'm going to start by checking, well, does it factor any? So we have x plus 3 times x minus 1 divided by x plus 4. So no factors will reduce out of the equation, which means I already know there's no hole. The second thing is when I go to find several of my values, I'm going to find my vertical asymptote. X plus 4 equals 0, x equals -4. Okay, I'm going to find my y-intercept and my x-intercepts next. So my y-intercept, I substitute x equals 0. So 0 plus 3 over 0 minus 1 over 0 plus 4, -3/4. So 0, -3/4, or -0.75 is my y-intercept. X-intercept. So our x-intercept, we set the equation equal to 0. We solve for x. So x squared plus 2x minus 3 divided by x plus 4 equal to 0. Multiply both sides of my equation by x plus 4. Which would leave me with x squared plus 2x minus 3 equal to 0. Or x plus 3, x minus 1 equal to 0. or x equals -3, +1. So I have two x-intercepts this time. We've got our vertical asymptote. Now the last thing that I'm going to check is my horizontal asymptote. So when I look at this equation, y equals x squared plus 2x plus minus 3 divided by x plus 4. I have degree 2 divided by degree 1, bigger on top. So we said that earlier was bow 2, bigger on top, undefined. So it's undefined. So this is the first case where we've had to actually go to the slant/oblique asymptote. So we wrote down that the way we find the oblique asymptote is by doing synthetic division. So since my factor is x plus 4, my x value I will use will be -4. My coefficients of my numerator were 1, 2, and -3. So my first step, I drop down my 1. 1 times -4 would be -4. 2 minus 4 would be -2. -4 times -2 would be a +8, which leaves me a remainder of +5. So when I actually go to write down my equation, this started off as an x squared, an x, and a constant. So remember, our degree drops by 1 when we do synthetic division. So this would be 1x minus 2, remainder 5. Now we're going to write our remainder as a fraction as -4, or as +5 divided by x plus 4. So this is actually our reduced equation right here. So our slant asymptote is going to be y equals x minus 2. So now let's take a look at how the graph is going to turn out on this equation. So first of all, I'm going to start by trying to graph my asymptotes. So x equals -4 is going to be my first asymptote. 1, 2, 3, 4. The second thing I need to graph is y equals x minus 2. I'm going to graph that as a dotted line. So I've got a rise over run of 1. And so I've got my asymptotes that are kind of set up like this. Now the next couple of things that I have is I have my y-intercept of 0, -3/4. I have x-intercepts at -3 and +1. So I've already got one spot to the right of my vertical asymptote at -4. And what this is actually going to do, since it has to cross the x-axis here, it will actually come down. We'll even off. And so we have something that kind of looks like that. And so it has two x-intercepts. Both of them are where the function crosses the x-axis. We have our one y-intercept. But otherwise it's going to try to be as close to the oblique asymptote as possible. So now when I check x equals -5, okay, I'm going to find out what coordinate should go over here. It should be way down in this little bottom triangle. However, it could be up here in either of these two sections. Which section is it going to be in? So we substitute in for x. So -5 squared plus 2 times -5 minus 3 over -5 plus 4. So in the numerator we have 25 minus 10 minus 3 divided by -5 plus 4 and -1. 25 minus 10 would be -15, would be 15 minus 3 would be 12. 12 divided by -1 would be -12. So -5, -12 would be our next coordinate. So it's going to be right at the edge of my page, and it's going to actually curve. And if we zoomed out on the graph, we would see it would be a mirror image of what's over here. So it would be reflected over this point. But overall, that's how you graph rational functions. Most of you have done this before. I feel very confident that you will be able to do it. If you have any questions, please let me know. The sooner the better.